Hey everybody, let's continue our discussion on vectors, and we'll continue with the position vectors. And what I want to look at in this scenario is the position vector from Shelby to Grayson. So I've drawn that out in green. My apologies if you're colorblind. But I've drawn this green vector down here, and it goes from Shelby to Grayson. Right? So I'm walking from Shelby to Grayson. So let's say Shelby's standing there, Grayson's standing there. And I start off over here at Shelby and I walk over to Grayson. My position change, we're going to call that displacement, all right? The change in position, is referred to as displacement. And I'm going from Shelby to Grayson. And so we oftentimes will symbolize this as RSG, Shelby to Grayson, from Shelby to Grayson. I'm going to talk about a different format for writing that, and we'll use that more often in dynamics, but I want to at least mention it here in just a little bit. So we're going to use RSG, that's position from Shelby to Grayson. And if I follow the green line, we'll start off in the X. I'm going to go 1, 2, 3, 4, 5, 6 meters in the X, and then 1 meter in the minus Y direction. So this is going to be 6I minus 1J. I could just write minus J, but I'm going to put a 1 in there just to accentuate it. And then meters. So the position from Shelby to Grayson is 6I minus 1J meters. I can get that by taking the position of Grayson minus the position of Shelby. So notice I've reversed my subscripts. If I take Grayson minus Shelby, I'm going to subtract the i's, 2i minus a minus 4i. 2i minus a minus 4 becomes 6i. And then minus 6 minus a minus 5 becomes negative 1j. Minus 6j minus a minus, that becomes plus. So minus 6 plus, I go towards 0. That's going to be negative 1j. Right? And that's going to give me then the 6i minus 1j meters. Okay, so I can find the position from Shelby to Grayson by taking Grayson's position minus Shelby's position. And we're going to do that a lot. We could do that with any of the others. Right? We could do that with any of the others. We're also going to find ourselves doing this a lot in 3 dimensions, but the process is just the same. If we go into the 3rd dimension, we're going to have a k component, ijk. We'll come back to that more in detail in a later video. But that's going to get us a start on finding that, right? Now, a couple of things. So that's from Shelby to Grayson. If I walk back the other way from Grayson to Shelby, that would be the position from Grayson to Shelby, right? From Grayson to Shelby. If I do that, I'm going to go left 6 and up 1. So left 6 is going to be negative 6i plus, because I'm going up 1j. Again, that's still meters. Oh, sorry. That parentheses out there. Notice it's just the opposite in sign. So if I switch my subscripts, SG goes to GS, just alter your signs on every term. If plus becomes minus and minus becomes plus. You alter that on every term. Okay, so that's the standard subscripting in statics. This would be the position of Shelby minus the position of Grayson. Okay, so that's how you would find that. Now, I do want to bring up one other different way of looking at this, and this is going to be what we call relative position. Well, again, in dynamics, we'll get into this in more detail, but I want to at least mention it here. So let's say we're on a grid, and I'm talking to Shelby, and I say, hey, Shelby, where is Grayson? Shelby's going to say, Grayson is 6 meters to the right and 1 meter back, 1 meter down, if you like. 6 meters to the right and 1 meter down. So what she is describing is Grayson's position. But she's describing Grayson's position as she perceives it. And so I oftentimes will write that as R subscript G, not G, slash S. This is the position of Grayson with respect to Shelby, or the position of Grayson as Shelby sees it. In a similar fashion to what we saw over here with our subscripting, if I said, hey Grayson, where is Shelby? Grayson would say Shelby is 6 meters to the left and 1 meter forward or 1 meter up. That would be the position of Shelby as Grayson sees it, or the position of Shelby with respect to Grayson. And these two, we've switched the subscripts, these two are negative of each other. Change pluses to minuses and minuses to pluses in each term, even in 2 dimensions, right? So they're the opposite of each other, okay? And we're going to get into this in more detail here in the next video. Thank you. If you have any questions, put them down in the comments below.